Yep.
Quick question on the arrays. For here, when it says I is less than bar A bar, are we reading these numbers there as, is that number supposed to go in there? Is that the way
No,
it's
bar
read?
A bar is the number of elements in the array.
Oh,
In this
okay.
case, that would be 2.
So if I had A
Bracket
like
3.
6 up to A6, and that'd be
7.
that's okay.
Yeah, because when you have A bracket 6, that means you have 7
Yeah.
elements.
Okay, and so that's what would go in there is, I'd see I's not are less than 7.
Yep, basically. Yep.
Okay.
All right, let's go ahead and get started. I'm going to pass a roll sheet. So instead of taking roll in the class, asking for people where you are here, you just put your initial next to the name. That's fine. Interestingly, when we get out, it is the same as the other one. You're not. Okay, so we talked about the binary search algorithm last time. Almost done with the binary search. Okay. So that's good. We know where we should start this time. Yep.
Are we talking about the binary search algorithm again?
Yep. We're going to pick up from where we left off because we didn't really finish the algorithm last time. So today we'll finish it up and then we'll do a trace based on the binary search algorithm and basically talk about the whole idea of time complexity so that you guys understand how do we evaluate a search algorithm? How do we know whether something is fast or not? And what do I mean by fast when I talk about a fast algorithm? So those are the things that we'll cover today. Some of that will be in the exam, and some of those may not be in an exam. So I will tell you guys when we get to the part that will not be in an exam, but I think it will still be useful to know.
When's the next exam?
The next exam is in week 10, 11 or so. So this is the 8th week, so we have about a week or 2 before the next one. Okay, so let's go ahead and get started. This time I will capture the algorithm in a spreadsheet Excel or in an Excel, in a spreadsheet, so we can trace the algorithm after it is done. We were almost done with the algorithm. Do you guys still remember the binary search algorithm, the main concept of it? Basically, you have an array that is already sorted. It has to be a sorted array. And in this class, unless I tell you otherwise, you can assume the array is sorted in a non-decreasing order. Okay? So what we do is we look at the big array, we pick the element right in the middle, and say, okay, is this what I'm looking for? Chances are it is not what I'm looking for. In that case, I have to compare and say, I'm looking for this, and this is what I pull right out of the middle of the stack. And then you compare these two. If what I'm looking for is larger than what I picked from the array, then which part of the array do I throw away? Do I throw away the first part or the second part?
First part.
The first part. Okay? And then I have the other part left. I will do exactly the same thing until one of two things happen. Until I either find the value I'm looking for or I run out of array elements to look at. Okay, so we looked at that option, and we also think about using 2 bookmarks to help us remember which part of the array may still contain the element that we are looking for. Do you still kind of vaguely remember that? Okay, maybe we should use a simple example to kind of remember what we talked about last time. So I'll just go ahead and make a simple example in this case. It's going to be in the same spreadsheet as the pseudocode and the trace. So on one side we have array indexes. So indexes. The array indexes have to start from 0 and go sequentially from 1 to whatever number you want to go up to. So we can make this really kind of big. We can make it a 15-element array. A 15-element array only has numbers up to 14. Why is that? Because we start counting from 0. Very good. So I just want to show everything here. The next column shows the value. So in this case, I just give it some random value. As long as they're non-decreasing, I'm good. So we can have duplicate values. We can skip certain numbers. 15, 21, 26, 28, 33, 45, 67, 85, 788, and 999. So those are the values. In other words, this is the index, that's the value of the element at that index. Okay, so we'll go ahead and look for k, meaning the key. Let's say we want to look for the value 19, okay, which is not in the array. Which element should be the first one that I examine?
The middle one.
We want to examine the one that is right in the middle. That would be number 7, okay? Because at this point the entire array has not been ruled out. So if I want to pick one to examine or compare, it will be the one at number 7. So at this one we can say 19 is less than 26. So if 19 is less than 26, 19 is going to be less than 28, 33, and so on. I don't have to look anymore. So because of this comparison, I can eliminate everything in this block here. So I will change the color of this block and basically say this block is now eliminated. What do I compare next? Now that I have everything from index 7 all the way up to 14 completely eliminated. Number 3, exactly, because what I have left is from index 0 to index 6. So 3 is right in the middle of those 7. So my next comparison will be compared against 15. 19, which is the value that I'm looking for, is greater than 15. If 19 is greater than 15, which is the element 3, it is going to be greater than element 2, 1, and 0 because the array is sorted. So that means because of this comparison, I can rule out this part of the array. I have 3 elements left. Of the 3 elements left, indexes 4, 5, and 6, which one should I compare next? 5, because 5 is right in the middle of 4, 5, and 6. Now, how do I compute 5 when I know the beginning is 4 and the end is 6? How about just taking the average? 4 plus 6 divided by 2 is 5. Okay. So now we compare against this element here, and then we'll say 19 is less than 21. So once again, we can eliminate everything from the element I just compared to and all the way to the end. So now we indicate that these are now eliminated. Can I quit now? Yep, go ahead.
When you say 4 plus 6 is divided by 5, so that's how you find out at the beginning where you start searching and get after you've been divided by half and you're dividing it by half again?
4 is the beginning and 6 is the end.
Okay.
So if you add the beginning to the end and you divide it by 2, that will give you the index of the element right in the middle of that range.
Okay. What if this comes out to be a
Fractional number? Then you use the floor function or the ceiling function so that you round it up or you round it down. Yep. Either way is fine. The binary search algorithm can deal with either round up or round down. It doesn't even have to be consistent. You can sometimes round up and sometimes round down. It will still work. Okay. At this point, we have one element left. In other words, the element at index 4 has not been compared yet. And that's the only place, if I had a 19, this is the only place where it is going to be. But since we actually do not have a 19, so we say 19 is less than 20, which basically means now I eliminate this part of the array as having the potential of having the element I'm looking for. And if you look at the state of this spreadsheet at this point, every cell has been eliminated already. Let me just show you the entire thing. So at this point, I can conclude that the element or the value I'm looking for, 19, is not in the array. Are we okay so far? So the next question is, if I use B to represent the index of the first element that may have the value I'm looking for, and E as the index of the last element that may have the value I'm looking for, how do I keep track of B and E in this case? Okay, let me just go add one more column so we can represent it. Before the first comparison, B is going to be here and E is going to be here. Do you guys agree? Because before the first comparison, I cannot rule out anything. So the entire array may contain the value 19, which is what I'm looking for. Does it make sense? After the first comparison, what can I do? Whoops, that's not what I want to do. After the first comparison, am I changing the beginning of the part of the array that may contain the value I'm looking for? No. I'm changing the end, right? So I can say index 0 is still the first place where I may see the value that I'm looking for, but the end of the portion of the array that may contain the value I'm looking for is going to be here now. Okay? In other words, you can see how I moved E from the end of the entire array to just one element before the one that I compared to. Yep.
If the value was greater, if the value was on the other side of the array, so would the B be the next element after the middle element? Say if when you search the value was less than it was greater than that value, so it would be then be the one element above the middle element?
Like the next case. Okay, let's take a look at the next case because that's what you're asking for. Yeah. Okay, in the next case we have 19, which is the value I'm looking for, compared to 15, which is this element here, and the value I'm looking for is greater than the value of the element. So in that case, I move the B. In other words, in this case, I move the B over here, but the E is still maintained over there. In other words, I'm not really throwing anything away from the arrays. All I am doing is moving the two bookmarks. One to indicate where the value may begin, or what is the beginning of the array that may contain the value, and one is representing where's the end of the array that may contain the value I'm looking for. You can basically see what I'm doing here. With after column H, then B and E are basically at the same place. They're both pointing at they're both pointing at the item of index 4. Is that okay? Now, what about this one here? What about the last one? When we have eliminated everything. Should we have moved E or should we have moved B? We should have moved E, right? So in this case, E would have been here,